Now let's spend a few moments looking at how we import data into the tidyverse. Most of the time when we want to get data into R and into the tidyverse, we're actually going to be bringing it in from the outside. The most common way is to have the data in an existing file, and then we have to read it in. So let's look now at how to import data from outside as opposed to what we have been looking at, which is creating tibbles by typing right within R. The read functions, and note they're read underline, not read dot, as in base R. This is what distinguishes them as being the tidyverse read functions instead of the base R read functions. Those read underline functions are used for importing different types of flat files into R. The most common of these is read underline CSV. You know that CSV files are what we've been working with all along for getting data into R, so we'll continue to do that in the tidyverse, but we're going to change what function we use. The New York City Flights 2013 data that I provided to you is a very large file because it contains a row of data for every single flight coming in and out of New York City in the year 2013. And as you can imagine, when you think about the daily traffic that they get, that is a lot of flights. Let's use the read CSV file to see if that works okay, even with that large amount of data. Okay. It did not work for me. Why? Because I forgot to use the library here function from where I put my data. So I'm going to pause this a moment and fix that, and I'll be right back. Okay, I'm back. I hope you found a little humor in the fact that I was like drum roll. Let's see if this will handle that big amount of data, and then it did not, but that was user error, as is typically the case when I'm involved in it. Let's try again. I've already loaded the here library, so let's go. Aha, that was fast. Notice that we're told what all the variables are and how they were created as either doubles or characters, it looks like, in our data set. Let's take a look at the tibble. Even though this is a huge amount of data, we wouldn't probably want to type this in if we were dealing in just a regular data frame in R, but since it's a tibble, we know that that can be handled pretty nicely. So let me go ahead and look at that. And here you go. First variables are listed, the first rows of data, and we're told how many more variables and how many more rows. Notice at the top, we see that we have a total of 336,776 flights in 2013, and we're looking at 19 variables for each of those flights, such things as scheduled departure time, actual departure time, delays, etc. For small amounts of data, you can actually read the data in line using read CSV. Note the absence of a comma at the end of each line of data. So here, I'm using the read CSV function, something we can't do with read.csv, and I'm actually reading in these data. So this will mimic exactly what it would be like if it was a file that we were reading from with these data. So you can read CSV from a file or read CSV from within R. So let's try this. And let's look at it. Here we go. Worked quite nicely. Sometimes our CSV files may include information at the top of the file, such as a title or name of the person who entered the data. And you don't have to go and change your CSV file. So if you have an Excel file and someone put a title at the top, or even you put a title at the top, you don't have to go and strip that out before using read CSV. Here's how you handle it. You just tell it how many lines to skip. You see right here at the end, Now, I'm actually reading in the data in the way I just showed you right here from within R, but I don't want you to get the impression that this is the only time you can skip. If these exact same data were in a file, and then I put the file name instead of the data here, this will work the exact same way. So if I have a CSV file and the first two lines say, these data were entered by Mike Seaman, date of entry, 1 April 2019. If I stated that and then said skip equals 2, those two lines will be skipped. All right, so let's look at it. And you see that those two lines were skipped. And here's our data with the variable names on not the first line, but the third line, which works because we skipped the first two. Another very useful way to skip data in a file is to identify a character that you use to indicate the data should be skipped. So let's suppose, for instance, you have sections of data and each section has a title and you have some common character at the beginning to indicate that it's a title. Note the character must be at the beginning of the line, no spaces in front of it. Well, let's say that I have these titles and it's not a common character. It would be pretty easy to start including a common character, such as an asterisk. So imagine if you had an asterisk and then the title of the section, and you did that in your CSV file in multiple sections within that file. But now you need to read in the data and skip all those titles. You don't have to know which line it's on, so we would need to have if we're going to have an asterisk at the beginning of each title, then I'll say comment equals and then an asterisk in quotes. And so notice what is happening here. We're going to be skipping on two lines, okay? Here's data from Mrs. Jones' class, starting with an asterisk, and here's data from Mr. Wilson's class, also starting the line with an asterisk. So let's read. And here's the student data. It worked beautifully. Just skip those lines. Pretty cool, huh? You can use the downward slash, that is a downward slope left to right, with an N to indicate a new line. So here, notice that I have taken and kind of just put everything in a string together, but I'm indicating a new line with the /n, and here's what we get. As you can see, Martha Tidrow was put on a new line separate from John Ringer because we put John Ringer on one line, then the score, and then the /n, and then Martha Tidrow. So I put two students on every line here, but we still were able to read it in correctly into the tibble. If you don't have column names in your data, you can indicate this to the read CSV function. So let's say that at the top, I don't have first name, last name, score, okay? So if I were to read this in without indicating this argument of column names false, it would think that the first variable is named John, the second one is named Ringer, and the third one is named 52. But by putting column names equals false, then we know that that's not the case. So here's what we get. What did the read CSV do? It put in x1, x2, and x3 as our variable names because we did not provide variable names. So in the next one, in the next example here, now instead of saying column names equals false, we're going to provide the variable names. Here they are. And notice the concatenate is needed because we're creating a column names vector. There we go. You can see the power and the flexibility of read_CSV as compared to read.csv. You can tell read CSV what is being used to indicate missing data in the file. This -99, that's actually pretty common. So is 99, which is kind of strange because 99 could be an actual value, but negative 99 could also be an actual value. That's why I like R's method of using a special data type, NA, which remember is not going to ever be confused with the characters NA because those would have quotes around them. This is just a special data type to indicate no data. And that's a lot better than doing things like negative 99. But here I'm indicating with the NA equals minus 99 that in my data set, minus 99 should be seen as missing data. And so when I run this, notice now I have the RNA character over here, look in the console window, indicating missing data. So let's review. A data import turns a flat file into a data frame. The tidyverse import functions are read functions that vary depending upon the nature of the flat file, and in the most common case, we're going to use read CSV. But you can also use the read functions, not just read CSV, but any of them, to read inline files. And what I mean by inline files is where you actually put the data right in your notebook or right into your script. Lines can be skipped. Column names are assumed, but this can be changed. Column names can be added separate from the file data. And then, of course, the read functions put the data automatically into a tibble, which is a special kind of data frame. So, read underscore whatever, typically CSV, great way to get your data into R and into the tidyverse.